All right, let's quickly go through this. So the next line is now we use a class called quantity. Sorry. This class actually specifies the quantity of the solution, or the solution object rather. So you have the solution object gas. So you use this class to assign a particular quantity of gas, a particular quantity of this solution object that you've defined. So if the object name here, if the object name here was say if I name it chair, just random term, if I name it chair, I will have to write chair over here. So the name of the object, of the solutions object, goes here. This is the solutions object, and we use it to define the quantity of the gas in this case. So if I so I've defined an object called fuel, and then I've defined an object called air. Both of them derive their qualities from the solutions class, and I can then go ahead and assign 1 kg of fuel. I can tell Cantera that, hey, I have 1 kg of this object called fuel and 18 kgs of this object called air, right? So that is the purpose of quantity. And again, let's go ahead and run these lines also. Okay. All right, now let's see. See, this whole thing again comes up. Let's go to the Cantera website quickly. I really want to show you in the web format, just so that it will be a little more legible. Let's go search for quantity. I think it'll be right underneath solutions. Okay, representing quantities of phases. Here, if you see the documentation has been given so beautifully. And I really encourage you to go through this. It won't take you much time, but you will see how to first define the solutions object, and then you define the attribute of this object, then you define the quantity of this object. And the reason why we are doing all of this is so that we can add these two quantities together using a very basic functionality that you will see in the next line. So here is the help available for quantities class, and you can see all of these attributes or properties are again at your disposal. The exact way that we use T and P for solutions is the exact way you will use any of these quantities any of these properties rather that you want with, say, fuel or air. And let's go and do it as such. Let's assign air as well. Okay, let me see what does air have. Let me see what is gas. Okay, it is 600 kelvins. Pretty hot. Let's take it back to 300. And again, this none term that I've used here, it signifies that, hey, by the way, it tells Cantera that, by the way, don't change the pressure. Keep the pressure as it is, just change the temperature. So now if I take a look at gas, okay, so it is at 300. Let's go ahead and assign fuel, then assign air. All right. Let's see how to use some of these properties for fuel. Fuel.p. Okay, so you see now you can, I mean, you get the pressure of the fuel, that's atmospheric. What about something else, like, say, what other? Volume. Let's look at volume. Okay. So it is giving you some amount of volume as well. And again, all of this is related with the ideal gas law. Okay, so now let's go ahead and assign the mass. Let's see, I think okay, so by default, okay, mass was already one. We may have already, okay, we probably already assigned this in one of the earlier commands. Let's go ahead and assign the weight. Okay, now let's go ahead. 1 second, let me. All right. Okay, so coming to line number 14, what do we see here? So here we are telling Cantera what is the, oh, sorry, something's wrong with my mouse, but we are telling Cantera what is the temperature, pressure, and the composition of the fuel stream. So we want the fuel stream to be at 300, pressure to be at 101325, which is atmospheric pressure, and the composition to be 100% methane. This is how you tell Cantera about the state of fuel. So here you can actually, if you look at this help that we've just now brought out, you will see all of these combinations of properties. So you see DP, get, set, density. So you have to at least provide two properties in order to set the state of a fluid. And TPX. So you can use you can use TPX, mole fractions, pressure, and temperature to assign the state of the fluid. You can also use TPY and give a mass fraction. You can also use TDY if you know the density, which I actually don't. I don't know the density of. I'll have to calculate, but I do know that the fuel is at atmospheric pressure. It is at 300, and it has 100% methane. So let's just go ahead and use TPX. But you can use any of these if you happen to know them. You can use internal energy and volume and composition, but these are all difficult. And so TPX works out the simplest in most cases, at least in my experience. TPX, TPY, I like to work with mole fractions mainly. So I tend to use TPX, but it again depends on you. All right, so let's go scroll to the bottom. All right, so that's what we are doing here in line number 14. And line number 15, same thing. We are assigning the state to the air. The air is at 500 Kelvin, and it is composed of 21% oxygen and 79% nitrogen. And this signifies that the mole fraction, X is the mole fraction, right? So mole fraction wise, 0.2 mole fractions of oxygen and 0.79 mole fractions of nitrogen. If, however, so this actually, if you add them up, it comes to 1. But if it did not come to 1, if you put say 0.2, sorry, 0.1 of O2 and 0.79 of N2, so that would be 0.89, the total mole fractions. However, mole fractions should always sum to 1. In that case, Cantera just goes ahead and normalizes the composition. So it would have taken 10% of oxygen. If you put 0.1 here, it'll go ahead and assign 10% of the total to oxygen, and then the remaining 90% to hydrogen. So that is how it just normalizes if this entire X does not sum to 1. And the same goes with mass fractions as well. So let's go ahead and do this. Assign the state to TPX, TPY, TPX, and air. And then finally, here, see, it's such a simple command. If you use the quantities class to add things up, you don't have to do much except just use the addition sign. If you just hit the addition sign, see now the operation took place. So Cantera took fuel, Cantera took air, and then combined them to form a fuel air mixture. And now you have all of these variables show up as well. And you can take a look at whatever we have currently. So fuel air mix dot temperature. Let's see. So see, this is the final mixing temperature that we get, 476 Kelvin, and this is all in SI units, by the way. So and let's go ahead and see what is the final composition that we got. One very beautiful or very nice attribute for these objects is a mole fraction dictionary. And again, that it is a part of the help file as well. So you can again go back to the web page, or you can just type help here in the console, and it'll show up. But let's go ahead and see. Do they have it here? It's a very long documentation. So mole fraction dict, see. So this is a dictionary, and I'll show you how to use it. So all you have to do is just type mole fraction, and you get the mole fractions or the composition that is for each of these species. So you have 9% by way of mole fraction or volume fraction, 9% of methane in the final mixture, 71.8% of nitrogen, and 19% of oxygen. You can also go ahead and look at the mass fractions. You don't have to always work with the mole fraction. So you just, instead of mole, you just write mass. And so now it will give you everything in mass fraction. So 5.2% of mass is methane in the final mixture, 72.6% of mass is nitrogen, and 22% is oxygen. So this is these are some very, very important functions and attributes that you will be using quite frequently in most of the scripts that you will write in the future on in Cantera. And so you saw all of the big jumble of attributes that and properties that each of these objects possess. However, I mean, you don't have to, like I said, you don't have to be intimidated with them. Nobody uses all of the available properties. The most important ones I will tell you here, and they will be the ones that will be most often used. So that's it for this particular video. I think it's the longest so far, but I promise from the next video onwards in this segment, we will keep it short. And that should be easy because we've already gone through the basics and the flow of the Cantera script. Well, okay, thank you so much, and I'll see you in the next lecture.